All right, let's talk about subnetting. So here's an example of a network. We have two routers, each with 3 interfaces. So this would make it all right, so let's talk about subnetting or IP addresses and things like that. So let's take an example. We have 1, 2, 3, 4, 5 networks. So when we're given an IP address, it doesn't matter what class it is. We have to have to meet the minimum requirements. So we have 5 networks, and max amount of hosts is 12. So we can easily do this with an IP address class C. So let's take for an example here. We have a 192.168.1.x/24 that's represented as 255, 255, 255, 0. So we call these, this is IP version 4. It is made up of 32 bits, 4 octets, each one is 8 bits. So 255, 255. How do we get 255 and all that? So if we got our little number line, we got 1, 2, 4, 8, basically doubling it. 16, 32, 64, 128. So when you add all those up, that's how we get 255. All right. So we want to take this address and break it down to smaller functions. So if we borrow an example 1 bit, we have 1, 0. If we borrow 2 bits, we get 0, 1. So you can see as we borrow bits, we get them. So we're going to minus 2. So right now that gives us 2 bits, right? And then if we do a 3rd bit, then that'll essentially give us, the next set of networks. So anyways, I'm not going to sit here and draw all the combinations of the bits out. So another number I want to introduce here, when you have 255 plus 0, the different combination is 256. So an example here, if we borrow 4 bits, so that would be 128, 64, 32, 16. So that would be 10, 20. That would be 10. And that would be 240. So we take 240 minus 256. That gives us 16. So that would be greater than 12, because if we minus 2, that's 14. So if we divide that into that would give us plenty of networks. So now here's how we write all this stuff out. So this would be our new mask. So let's change this all up. And then that would be 4 bits to 24. So that would be 28 bits, and that would give us 4 bits left for addressing. So we can write everything out. And let me clear out some more space here. So this would be our IDs. This would be 192.168. And this would be, start with 0. That one, oh, my mistake, because I got a 1 there. So that would be, quickly erase that. So it'd be 1. That would be 0 technically. Our next ID would be 192.168.1.16, 192.68, and then if we add 16 to that, that would be 32, and then that would be 48, and then 16, that would be 54, 195, 168.1 plus 16. So if my math is all right on that. So the usable range would be 1 through 14. And our broadcast would be 15. And this would be 17 through 30. This would be 31. So what are the things you can see here? You can see all our IDs are even numbers. Our usable range is going to be a mixture of even and odd numbers. And our broadcasts are always going to be odd. So let's just take the 16 block and let's go over to our picture. So we're just going to pick one of them. So let's pick this area here. And let's say this is going to be our 16.0. So this represents this whole entire network, part of this router. So this guy's interface, we can either start with the beginning or the end of the range, depending on how you want to choose to do that. So let's start with the beginning, I guess. So we can make this 17, and then we can make our server 18, because we want to sub DHCP. We don't want to manually go and IP address everything. So let's talk about how we would do all that on the DHCP settings. Well, let's scroll up, I guess. Try to flick to the next page. Not very cool, I guess. So we were saying we have this 192.168.16 or .1.16. So when we set up our DHCP, so let's say our DHCP scope, so we're going to say our range is going to be 192.168.1.18. Because you remember, we're using the first address in the range for our router, so our router's interface, and then we're using the next number to be our static IP address of the server. So the next available number would have to be 19. And that's why you write these things down, so if you make a mistake, you can easily correct it. So that'd be our first usable range. And then if we go back to our notes here, 30 is our broadcast. So then that would be, our scope would be 192.168.1.30. So we could also make this the server run the DHCP, and we can make it DNS. So the next thing we have to set as our mask. So that would be 255.255.255.240. Because we've got to have a valid mask. And then our default gateway, or our router, depending on your DHCP server, we're going to use the same address that's on our interface, so that's .17. So that is going to be 192.168.1.17. And then our DNS settings is going to be 192.168.1.18, because we said that the server is .18. It's running our DHCP and our DNS. So remember, guys, when we're setting up our DHCP, we want to use a valid range. We don't want a static stuff in the middle, because then it breaks up our range. So we're always going to static stuff at the beginning or at the tail end, so we can have a nice seam of addresses that we're going to give out. So remember, they have to be valid in your network range, so you can't go past your network range. So if our network supports 16 devices, well, you can't give out more than 16 IP addresses, or a total of 14, because minus 2 for the network ID and broadcast. So what is our network ID again? Let me write it in blue here. So that would be that's our ID. Our broadcast is 31. Again, even for IDs, odds for broadcast. So that means everything. So that means all of this right here uses the same ID, shares this ID. The ID is there for the router. So when it routes packets from one network to another network, it uses these IDs. So an example, since this router has 3 interfaces, so it's going to have 3 route statements. It's going to have one for this network, one for this network, one for this network. And its default gateway for this network is going to be this guy's interface. Same thing here. So each interface on the router is a way in and out of that network. So if this is network A, it's going to use this interface to get out. Network B, if we call this B, it's going to use this interface to get out. So the default gateway is perspective of where your network is and which interface of the router you're going to. So remember, your router is going to have it can have its own default gateway the way out the door, and how to get generically what we would call a static route. And then here in our network, when we set up our DHCP, when we set up our settings, we're going to take the IP address of our router's interface, and we're going to tag that as we're going to rename it as our default gateway, or our default route out the door, however you want to look at it. Or some DHCP servers are going to call it the router. So you're going to plug that in. Now the difference on a home network, all these things are all going to be the same IP. So your DNS, your default gateway, your wireless, all that's all going to have the same IP. Well, that's how a home organization works in enterprise. Again, each component is broken down separately because the amount of traffic each one of these devices hold. Nobody's going to have a large organization is going to use a home router with 8 ports. You're going to have, a couple hundred devices, so you're going to need multiple switches and stuff. All right. So hopefully this kind of helps give you an idea about breaking down IP. There are plenty of other videos that are out there that would give you more examples of subnetting. I just wanted to take a simple address scheme, kind of draw it out, give you guys a little bit more of an idea or a good review depending on which class you're watching this from. All right, so just a quick recap again. We got our DHCP. The DHCP can sit on a dedicated server, can sit on a switch, can dedicate on a router. It could be one of these places. We could, in theory, have one DHCP server service all 5 of these networks if we wanted to. We'd have to do some configurations, but we could do that if we wanted to. If we wanted to have local DNS in DHCP, we can do that too. We can do either or. We could have one dedicated DNS server in one spot and have everybody else resolving to it. Not a big deal. All right. Thanks for watching. Bye.